G'day, this is just a little video explaining question 3 and question 4 in 1H. Now you mentioned that you had done 3A, so I guess I needed to do that first before I was able to move on to 3B. In this video I'm just going to provide you with some hints, and so hopefully you can kind of try and work it out for yourself, but I've also attached my solutions to it as well, so like in the email, so you can have a look at it if you don't understand completely, or if you just want another hint, I guess you can go to that. So I got down to here, finding out the perimeter, getting the area, using the perimeter, I guess, to find that out, and I eventually got this answer here, which that's what you said you got as well. Now for B, it says write down an appropriate domain. So basically they want a domain of this graph here, but they want it in terms of x, because there's no y in there. So what I thought is, I actually thought that I would draw this diagram again, and I was going to look at this and thinking, okay, what's the smallest possible value that x can take here? Now, I mean, normally you would say, oh, 0 is the smallest number that x can take. But if you have a look at the side lengths here, that's x there, and we've got another side length over here that's been named. So x actually can't be smaller than that side length there. And a similar idea for y. Y can't be smaller than a particular number here as well. Now, if you take that into consideration, the smallest possible x value and the smallest possible y value, let's just take the smallest possible y value for a minute. If you have the smallest possible y value, that means that we want to find the maximum possible x value. But the trouble is, we've actually got a fixed perimeter of 160. So if the maximum perimeter is 160, and the smallest y value is actually, we can find out here, then you can find the maximum x value based on that. And I would actually use this perimeter formula that we were using up here to find out the value of x. Given that you know the value of p, which is 160, you can know the minimum value of y, and then you can find out what x is. So hopefully you'll then get a minimum and a maximum based on that, and you can put those in there. I've decided that it can't be equal to either of those things, because if the x is the minimum number here, then you actually have no shape, because that disappears, or at least this part here disappears. The whole thing kind of doesn't work anymore. And the maximum possible one, it means that I guess the same sort of thing occurs. That this part here disappears. So anyway, I just decided not to make them equal to. Okay, let's have a look at C. C just says to simply sketch the graph. So what I've done is I've just sketched it, but I've actually sketched it given the domain of up here. But I've just blocked it out just so that I guess you can sort of work it out yourself. But that's what it would look like. So hopefully when you've got the right answer, when you sketch it, it'll look like that. Now I'm using a slightly different calculator than the one that you'll use, but hopefully you'll still get the same answer. And if you don't know how to do this, if you don't know how to restrict the domain, so you only just get this bit, let me know, and I'll show you how to do that. It can be quite helpful actually, sometimes doing this. Now the other thing, so that's C, and then the last thing we want to know is the maximum area. So what I did on this one is, just based on that there, you could use it using calculus, find it using calculus and various other things, but I decided to just find the maximum value on my calculator here, which gave me an x value and a y value. The maximum area will be the y value, and then the x value, because then the question says, and the x value and the y value associated with that. So the x value will be the x value, surprise, surprise, and then the y value we can find out using the perimeter, because it's a fixed perimeter, and we have x and y related, so we know the value of x and we can find the value of y. Again, if you don't know how to find the maximum value here, let me know, and I'll tell you. So hopefully that's helped you to answer question 3. When I moved on to question 4, I think you said again you did 4AI, but I needed to do that as well just for my own sake. So I ended up getting all of the sides, noting that the top was open. So I got all of these things ended up being 2x squared plus 6xh. And then I looked at for AII, and it said find S in terms of V. So I thought, well, I've got to have an equation for V, and I thought, well, V is the volume, and it says it was fixed. So I just found the volume, which was 2x squared times h. And then I thought to myself, well, I somehow need to put this information here up into this information here because AII says find the surface area in terms of x and v, which that means, that implies no h. So I have to somehow get rid of my h in here, and I need to put a v in this equation somehow. So I'm going to suggest that you should use this equation here to somehow get rid of that h and replace a v. So hopefully you can sort of muck around with that and get the right answer, and ultimately get an answer for S. For B, it asks you to find the domain, and I mean, I guess I can't really do too much more because you haven't got the value of S yet, but once you find the value of S, hopefully you can get the domain from there. And like, I guess there isn't really a restriction on how big X can be, because X can just get bigger and bigger and bigger and bigger. It just means that H will get smaller and smaller and smaller. But there might be a minimum value of X. So just have a think about that one. Then I think for C, it says that, let's say that V is actually 1,000 or 1,000 cubic meters anyway, and we need to find out the maximum value of S, I believe it is, when X is between 2 and 15. So again, what I would do is I would substitute V as 1,000 into my equation that I got before, and then what I would do is I would actually graph this equation, this S equation, with that 1,000 in there, and I would do it between 2 and 15, and then I would just simply find the maximum Y value along that in between those two X values. And once you found the maximum Y value, that's essentially what they're after, the maximum surface area. So hopefully that's kind of helped you out. It helped you with a couple of hints so that you can go and do those questions yourself. As I said, if you can't get them, then you can always have a look at the attachment that I also put on, which has the solutions as a PDF. So let me know if you have any more questions or you want to clarify anything that I've said in this video. So thanks very much.